Hello guys, welcome once more to the online class where we deal with Jamb Physics 2019, and in this episode we shall be looking at question number 11 to number 15. And once more, my name is Mr. Damdala. Now don't forget that if you really like this video, click on the like button so that you can get content from us from time to time, and you can also tell your friends about this page. We have much to show you that will help you as you go on. Let's check out number 11 now. Question number 11 says, radio wave have a velocity of 3 times 10 to the power 8 meters per second. A radio station sends a broadcast on a frequency of 800 kilohertz. Now, the wavelength of the broadcast is what? Now, this question is on wave, right? Right, wave. But there's one formula that is the mightiest formula in wave, and that formula is very popular. That formula can answer so many questions in wave, and that formula is this. If you can see you have frequency, frequency, velocity, and you are told to find the wavelength. Now the strongest formula comes to play here, and that formula is B equals F lambda. Now this formula, as small as it is the strongest formula in all of wave, because this formula answers questions on different aspects of wave. It can answer questions on echo. It can also answer questions on ordinary wave like this. It can answer questions even on sounds. Different kind of questions on wave can be answered with this formula. So the formula says B equals F lambda. And we're told to find the wavelength, which is lambda. Okay, so lambda becomes the subject that I divide both sides by F. So I get lambda equals B over F, right? That's the way I will use it for this question. Lambda equals B over F, because I'm to find the wavelength, which is lambda. So therefore, my wavelength is my velocity, which is 3 times 10 to the power 8, which is the speed of light, okay, over the frequency, which is 800 kilohertz. Now that kilo is 1,000, so that means it will become lambda equals 3 times 10 to the power 8 is 3 and 8 zeros. That's 300,000, and that's the speed of light, 300,000 meters per second, over 800 kilohertz. Kilo means times 1,000. That's 800 times 1,000, making 800,000. So if you cross through that, you'll be getting 375 meters as your wavelength. Very straightforward, and it's all about that formula. Okay, if you get that formula, then you can blast any question. So let's go to number 12. So my answer for number 11 is C. Number 12 says the graph diagram above describes the motion of a particle, right? Now this is a velocity time graph. You can see from the drawing, this is year 1. So velocity time graph, that is it. Now we have this. The question says find the acceleration of the particle during the motion. Acceleration, we learned then that acceleration is from the first slope is acceleration. That means A, the part I put A, that's the first slope. So to find the acceleration of this drawing, that's the first slope. That's the A part. So the acceleration is between that A. So I'm not looking at the rest of the drawing. I'm looking at only that place that I put A, from the beginning to the end of that line. So, and definitely you know that acceleration is what? Velocity over final velocity, that's B minus U, initial velocity, over time 2 minus time 1. Now on that slope, now look at the velocity time. Now you have a slope like this. Now on the velocity part, that's the one standing straight, that slope is facing 10 and 2. Can you see that? In the one standing straight, the slope is facing 10 and 2. In the one standing straight, the slope is facing 10 and 2. That means my slope for A is facing 10 and 2. That's my velocity. So it is between 10 minus 2. And the same slope on the time aspect, that is facing down, the time is down, the same slope is facing 2 and 0. Can you see the time down? It's facing 2, the slope is facing 2 and 0. So the time is 2 to 0, while the velocity aspect is 10 to 2. So that's 10 minus 2 over 2 to 0, giving me 8 over 2. That's 8 over 2, which is 4, please. 4. If you divide 8 by 2, you're getting 4 meters per second square, and that is your acceleration. 4 meters per second square is the same thing. 2 ways of penning it down. It can be 4 meters per second slash s square, or 4 meters per second. You are saying the same thing anyway. So that's the answer to that question. But in case you are told to find the deceleration, I solved further. In case you are told to find deceleration, the deceleration is the other part of the drawing, which is the opposite acceleration, and that's the last part that I put A and I put a crown on it. That's a prime on it. A and a crown on it. Okay, so that's my deceleration. So you can't find this deceleration from the first part. You can only find deceleration or retardation, which is the same thing as the deceleration, from the last part. So that's my A. So that's solved at U minus B over T2 minus T1. Now look at that A. It is facing this side. So that will become, we will take you from the lower part. That's 0. That's facing this acceleration part. That's 0. That's 0 to, it is from 0. That's 0 to 10. That's on the vertical side. That's for your velocity. That's for your velocity. So it's from 0 to 10, and then for the time below, it's from it's from 6 to 5. So from the velocity part, that's the one standing straight. The deceleration is from 0 to 10. Can you see my drawing? It's from 0 to 10 standing straight. Then for the time below, it's from 6 to 5. Okay. Now that gives me minus 10 over 6 minus 5. That's 1. Give me minus 10 as my deceleration. Now don't forget, these things are different working. The place you focus on when you are finding acceleration is not the same place you focus on when you are finding deceleration. It is two different locations and two different calculations. Okay. Now you will spend some time at a different time. We will work more on this, but for now, that is sufficient for now on acceleration. So our acceleration is 4 meters per second square, and that is the answer for acceleration. Okay, so let's check out the that means option D, the correct answer. Now the next one, number 13, says water shows anomalous behavior between when is it below 0 degree or above 100 degree or exactly 4 degree or between 0 and 4 degrees Celsius. Now the word anomalous means abnormal. Water behaves abnormally. That means every material in the world expands when heated, but except water. Between two temperatures, water does not expand, water contracts. That means when you eat a metal, for example, if you eat a metal, like you eat a steel, you eat steel. If you eat it with fire, it will expand. But water does not expand when heated first. Now, water behaves anomalous, means abnormal. It behaves like a madman. When you eat water, water contracts first. That's not normal. That's anomalous. That's not normal. And that contraction happens between the temperature of 0 to 4. Now that happens like what I have there, I wrote it down. Unlike most matter, water contracts between 0 degree to 4 degree when heated before expanding above 4 degrees. So that misbehavior happens between 0 and 4 degrees Celsius. This is abnormal, and this is the anomalous expansion of water. Now, water contracts between 0 and 4. Okay, then from 4, it starts behaving normally, it starts expanding. And that happens because water at 0 degrees Celsius is ice. So for water to adjust to that temperature, it has to melt first. That melting happens between 0 to 4, and therefore water contracts first because it's trying to adjust to the heat. So it has to contract first. So then it will now begin to expand from 4 degrees Celsius onward. Okay, so that's called the anomalous. It happens between 0 to 4 degrees Celsius. Okay, so that's the answer to that question number 13. Is between 0 to 4 degrees Celsius. Okay, let's check out number 14 question. It says a uniform meter rule QR is balancing on a knife edge, which is 55 centimeters from R, when a mass of 10 grams is hung at P as shown below. Sorry, the mass of the meter rule is what? Now this is a question on equilibrium, and you have a meter rule there, and normally, naturally, the meter rule is always 100, but you have a mass of 10 grams hanging downward, right? Then you have to find the mass of the meter rule, which is the M2. That's the second M that I put in the drawing, right? So now look at that. Now it is between, from the drawing we have first, we have the mass given the 10 gram is it has a distance of 10 centimeter from the point it is to the end of the drawing. That means all the remaining length from the place that the mass is hanging. Note the total length of the ruler is 100. So if this is 10, then all the remaining length is therefore 90. So that's why I have 90 in my drawing for the length. Okay. Now the pivot is at 55 from the question. We have the edge of the knife is at 55 centimeters. So therefore, from 90 to 55, the distance of the mass 10 gram is therefore 35. Now, the second mass is hanging at 50 because the middle of the rod is 50 because the entire rod is 100. So the middle of the rod is 50. So therefore, the weight of the rod can be taken from the middle. So if they say find the mass of the rod is at the middle of the rod. Okay, so therefore the mass of the rod can be taken at 50, that's which is the middle of the rod. So therefore 50 to the 9th position is 5. So that's the distance. So you must find the distance of the masses to the 9th position. That's from the middle to the 9th is 5. While from the other mass 90 to the 9th is 35. Okay, that's 90 to 55 is 35. So give me 35 and 5, right? Okay, so therefore we'll now find the moment. So let's find the moment now. So the moment, naturally, the moment is force times distance. So from the left hand side, moment at left hand side, that's this way, and the moment as right hand side, that's this way, must be equal. That's the law of moment. So moment at left hand side must be equal, please, to the moment as the right hand side. So that will give me at the left hand side, that's 10, that's the mass 10 times the distance, that's 35, that's 90 minus 55, equals the moment at the right hand side, that's I don't know the moment, that's supposed to be m, I don't know, that's m times the distance, which is 5, that's 55 minus 5. So I have 10 times 35, that's the distance, equals the m, that's the mass I'm looking for, times the distance, 55 minus 5. Okay, and that gives us 350, that's 10 times 35, that's 350 equals 5m. Okay, now what I for that? I don't know what my second m is. That's m, ordinary m, and the distance is 5. That's 55 minus 50, give me 5. 5m equals 350 on the left hand side, right? So that gives me my m is therefore 350 over 5. So giving me 70 grams as my mass, and therefore my mass is 70 grams, and that gives me the answer to that question as 70 grams. Now let's take a look at it again. Now look at everything. The left hand side is equal to the right hand side, right? And the right hand side is mass times distance. No, moment is mass times distance. The mass is not known, but the distance is between 50 to 55, and that's 5. Okay, that's 5m. Then for the left hand side, I have the mass as 10 and the distance as 35. That gives me 350 times it together. That will give 350. Okay, 350, 5m equals 350. Divided by 5, you'll be having your m as 350 over 5, which is 70 grams. And that is the simple thing I'm saying all through the time. Okay, so that's how to find moment. It's very straightforward. It's just that way. Force times distance at the left hand and the right hand side. So that's settled number 14. Now number 15. Now the vacuum of a thermos flask help to reduce it by what? Now you know a thermos flask is this way. We know it works between conduction, convection, and radiation. But for the vacuum means space. The space in your flask. Now we all have flask at home, and those flasks have vacuum. That means empty space inside the body of the flask. There is an empty space. Now, what's the function of the empty space? It is simply to reduce it by convection and conduction. Now, don't forget that it's very important. The function of that space is to reduce it by convection and conduction. Now, but what is conduction? Conduction is heat transfer through direct contact. So conduction is just heat transfer between solid bodies that are in contact. Now, if you have, I said conduction is heat transfer between solid bodies that are in contact. Like you have heat transfer is the transfer of thermal energy or heat energy through contact. That's direct contact. That's bodies in contact. So if you have a solid body touching another body, there will be heat transfer between the two bodies, right? And that is an example of conduction. Like if you have if you put your hand on a hot pot, the heat in the pot will transfer to your hand through conduction. So there is always conduction has to do with bodies that are solid, while convection has to do with heat transfer by the movement of liquid or gas. Okay, while radiation is the transfer of heat energy through thermal emission, or when something radiates or shine. Okay, that's an example of radiation. Like if you have this, the sun comes to the earth by radiation, right? So the space or the vacuum in a flask or a thermal flask is an example of heat transfer. It stops heat transfer by convection and conduction. Okay, while the cork on the flask stop heat transfer by conduction. So that the heat will not be lost when you touch the top. So that the heat will not be lost. So they use an insulation as your cork. Okay, both up and down, so that the heat will not be lost to any other thing. If there's no cork under, if you put it flat on a table, the heat will flow to the table and the heat will be lost. So the cork prevents heat loss by conduction. While the last one is the silvery body. The silvery body, most flasks are colored silver, and the reason is because silver stops heat loss by radiation. Radiant energy cannot pass through a silvery body. Silver stops heat loss by radiation. So the function of the silver body is to stop heat loss by radiation, while that of the vacuum is two: conduction and convection. Then the cork is one, and that's conduction. Now, if you master this, then you've understood a lot about the thermoflask, the function of the part of the thermoflask. And that brings us to the answer of that question, that it is convection and radiation. That means the vacuum stops heat loss by convection and conduction. And that is my answer, option B. And that brings us to the end of this video. Don't forget to like the video so that we can send other content to you from time to time. Until we see you again, guys, take care of yourself and bye for now.